Hello friends, in this video we will consider the OR portion of the question number 27, that is the optional part of the question number 27 on definite integrals in the CBSE question paper for the year 2018. Now the question is integrate x square plus 3x plus e raised to the power x dx for the limits 1 to 3 as the limit of the sum. Now, to express an integral as the limit of the sum, we use the following formula. Suppose I have to evaluate integral of fx with respect to x as x changes from a to b. Then I divide the interval into small sizes, each interval having size h being given as b minus a upon n, and n is made extremely large and h is automatically reducing to 0. Then integral can be given as limit n approaching infinity, which means h approaches 0, h into f a plus f of a plus h plus f of a plus 2h, so on, last term being f of a plus n minus 1h. Whenever we do the question on integral as a limit of sum, I suggest every student to clearly write down this formula in his copy, in his or her copy, so that the chances of making a mistake are reduced. So now rest, we just have to plug in the values and go on with finding the limit of sum. So in the given question, a is 1, b is 3. So h, which is the step size for the intervals, becomes b minus a divided by n, that is 2 by n. So integral can be written as limit h approaching 0 and approaching infinity h into f of a. A here is 1 plus f of a plus h plus f of a plus 2h going up to f of a plus n minus 1h. Limit at approaching 0 and approaching infinity. Now fx is the given function, so f1 becomes 1 square plus 3 into 1 plus e raised to the power 1. F of 1 plus h is 1 plus h square plus 3 into 1 plus h plus e raised to the power 1 plus h. Next term will be 1 plus h square 3 in 1 plus 2h whole square 3 into 1 plus 2h plus e raised to the power 1 plus 2h. Last term 1 plus n minus 1 h whole square 3 into 1 plus n minus 1 h plus e raised to the power 1 plus n minus 1 h. Now we will combine the similar terms having similar powers of h. So first of all, I consider these square terms. 1 square 1 plus h square 1 plus 2h square. Last term here will be 1 plus n minus 1h whole square. Then this term in each bracket, so I can take 3 common. 1 plus 1 plus h 1 plus 2h going up to 1 plus n minus 1h. Then the exponential term, these terms, so e plus e raised to the power 1 plus h plus e raised to the power 1 plus 2h e raised to the power 1 plus n minus 1h. If any student finds it difficult to write down all the terms in the same integral, I suggest them to evaluate each of these integrals separately and I don't think any teacher will cut any marks for doing the question in that manner. Once again, rearranging the terms. Now, in this all these square brackets, in each bracket I will get a one square term, and there are n such brackets. So when I add all of them, I should get n times 1 square. Now, then I will get a term containing h square in each of the brackets. So taking h square common from each one of them, I will be left with 1 square plus 2 square up to n minus 1 square. Now, in each of these brackets, there will be a term containing uh, uh, the term 2ab term in the whole square identity, and you can easily identify that there will be 2h common in each of those terms, and we will have 1 plus 2 plus 3 up to n minus 1. Now coming to the single power term of x, that is corresponding to 3x, I will have n times 1, so 3 is common, and n times 1 plus there are terms containing h in each of the bracket. From each of those terms I can take h common, and I will be left with 1 plus 2 plus 3 going up to n minus 1. Now coming to the exponential function term. Now each of those terms e can be taken common, so we will be left with e, and inside the bracket we will have 1 plus e raised to the power h plus e raised to the power 2h e raised to the power n minus 1h. This question, the questions on limit of the sum appear untidy, but they are fairly mechanical in operation, and you just have to follow the procedure. They are not very difficult questions to manage ultimately. So first term becomes simple n. Now h square, and inside bracket I have sum of squares of n minus 1 natural numbers, and its formula is n minus 1 into n into 2n minus 1 divided by 6. Then 2h sum of n minus 1 natural numbers, which becomes n minus 1 into n upon 2. Coming to the next bracket, 3n plus h into sum of n minus 1 natural numbers, which is n minus 1 into n upon 2. Then the last term, now this is a geometric progression having first term 1, common ratio e raised to the power h, and there will be a total of n terms in the expression, counting from 0 to n minus 1. So its sum will be e raised to the power nh minus 1 divided by e raised to the power h minus 1. Now these two can be combined. So we have 4n. There is a single term having h square. Now single power of h, we have two terms, so we can combine them. So 1 here and 3 by 2 here makes it 5 by 2. So 5 by 2 h into n minus 1 into n. Then the last term, exponent term, that is already in pretty good form. E raised to the power nh minus 1 divided by e raised to the power h minus 1. I will shift h inside the bracket. Last term, h, and this I am writing separate because they will be converted to standard limit for h approaching 0. Now at every place wherever we get n into h, we will substitute b minus a, that is 2 in this question. Wherever we get h alone, that will be replaced by 0. Before that, distribute this h cube into these brackets. One h being given to each of these brackets.
Two NH minus H divided by 6 plus 5 by 2 NH minus H into NH. Last term, now making the substitutions to evaluate limit, this becomes 4 into 2 plus 2 minus 0 into 2 into 2 minus 2 into 2 minus 0 divided by 6 plus 5 by 2 2 minus 0 into 2 plus e raised to the power 2 minus 1, and this is a standard limit 1. This is our final result. Thanks for watching, and I will give another question solution in the next video. Do stay in touch. Thanks.